Good evening to all. Today our class is fuzzy sets and its applications. So first we start with introduction. The word fuzzy means vagueness, that is ambiguity. So not clearly understood or expressed. Fuzzy means not clearly understood or expressed. Fuzziness occurs when the boundary of a piece of information is not clear cut. Piece of information is not clear cut. So fuzzy sets are introduced here. The author is fuzzy sets introduced author name is Lotfree Jodoh, a professor of UC Berkeley in California in the year of 1965. Fuzzy set theory is an extension of classical set theory where elements have degree of membership. Fuzzy set theory is an extension of classical set theory where elements have degree of membership. Classical set theory allow the membership of the elements in the set in binary terms. Fuzzy set theory permits membership functions valued in the interval 0 to 1. This is very important. So, fuzzy set theory permits the membership functions. Here, fuzzy theory mainly introduces the membership functions that valued in the interval 0 to 1. For example, work like young, tall, good, or high, or fuzzy. So, there is no single quantitative value which defines the term young. There is no single quantitative value which defines the term young. That is, for some people age 25 is young and for others age 35 is young. So it is clear that so here words like young, tall, these terms are not defined 0 and 1. So this is there is no single quantitative tall, young, good. This is not defined single quantitative. So that is for some people age 25 is defined as young and for others age 35 is defined as young. The concept young has no clean boundary. So age 35 has some possibility of being young and usually depends on the context in which it is being considered. In real world there exists much fuzzy knowledge. Okay, that is uncertain, exact, etc. Human thinking and reasoning, analysis, logic, and interpretation frequently involved by fuzzy information. Human thinking and reasoning, okay, are frequently involved in fuzzy information. Human can give satisfactory answers which are probably true. Our systems are unable to answer many questions because the systems are designed based upon the classical set theory. Now we want our system should be able to copy with the unable and incomplete information. Fuzzy system has been providing solution. Fuzzy system had been providing solution. Now the fuzzy set theory has numerous applications in various fields. Most important application areas are in fuzzy sets. Most implication applications are fuzzy systems, fuzzy medical diagnosis, fuzzy data analysis and classification, artificial intelligence, automated theory, robotics, etc. Anti-clocks breaks auto engine. Classical sets or crisp sets. First here we define classical sets or crisp sets. This is all or the introduction of fuzzy sets. Okay. Now we go to the definitions. First definition is classical sets or crisp sets. These are also known as crisp sets. First we define set definition. First we define the set definition. The set definition: a set is any well-defined collection of objects or collection of objects in a common property. A set is any well-defined collection or of objects or collection of objects in a common property. For example, a set A is defined as X such that X belongs to Z, X is greater than or equal to 0. This is the definition of set. Okay, what is defined set? A set is any well-defined collection of objects. A collection of objects or collection of objects in a common property. That is, example of set is A equal to X such that X belongs to Z, X is greater than or equal to 0. Now we define elements. In this set we write that the elements collection of objects are elements. So elements means the objects in a set are called elements. The objects in a set are called elements, are members of the set. Next we define empty set. The set that contain no number. The set that contain no number is called empty set or null set, and it is denoted by pi. The set that contain no number is called empty set or null set, and it is denoted by pi. Next, we define universal set or whole set. The whole set X as the set of all elements in the universe. The whole set X is set of all elements in the universe. So here we define the definition: set, elements, empty set, and universal set and whole set. Okay, next we take some points. The null set analogous to impossible set or impossible set event. The whole set is analogous to sure event. The use of letters capital A, capital B, capital C or represent sets or lowercase letters small a small represent the elements. Set defines are capital letters and the elements are defined as the small letters. Next, here the universal set is defined as capital X and the elements are concerned with particular context. For example, for the set capital A, here X is an element, X belongs to A if X is an element in capital A. Y does not belongs to capital A if Y is not an element of set A. Okay, now the following symbols are through this subject. Here we define capital Z, that is set of all integers. Set of all integers that are minus up to so on -2, -1, 0, 1, 2, 3 up to so on. These are the integers. Set of all integers. Next we define natural numbers. Capital N equal to 1, 2, 3 up to so on. A set of all natural numbers are the set of all positive integers. Next, we define the non-negative integers. Non-negative integers, that is defined as n naught, 0, 1, 2, 3 up to so on. Next, we define the set n natural numbers. N equal to 1, 2, 3 up to n. This means n 1, 2, 3 up to n. N 0 n means 0, 1, 2, 3 up to n. Here, the capital R equal the set of all real numbers. R plus is means that the set of all non-negative real numbers, that is 0, 1, 2, 3 up to so non-negative integers. This is defined as closed interval A to B. This means closed interval A to B means including A and B. We take including A and B. Next, this is left to open interval A to B. Left to open interval. This is right open interval. So right open interval is A to B. Okay, open interval A to B. This means in between the values A and B, x1, x2 up to so on xn, ordered n tuple elements x1, x2 up to so on xn. Now we define the representation of sets. Representation of sets. There are three basic methods by which sets can be defined within a given universal set X. There are three basic methods by which set can be defined within a given universal set X. The list method. Next, we define the list method. A set is defined by naming all its numbers is called the list method. A set is defined by naming all its numbers is called list method. This method can be used only for finite sets. List method is used only for finite sets. A1, A2 up to so on A are numbers in set A. Then it is written as capital A equal to the set capital A1, A2 up to so on AN. Next, the rule method. First one is list method. Second method is the rule method. A set is defined by a property satisfied by its members is called the rule method. A common notation expressing this method is A equal to X such that P of X. X such that P of X. Where the symbol such that denotes the P of X is proportion of the form X has the property P. That is, A is defined by this notation as the set of all elements of X for which the proposition P of X is true. It is required that the property P be such that for any given X belongs to X, the proposition P of X is true or false. P of X is either true or false. Okay, here next we go to for crisp sets capital A and B containing the collection of elements in X. The following notations: X belongs to A, this means X belongs to A is subset of B, that is A is subset of B. A comb are equal sets, that is A equal to B, found only if A is subset or equal to B and B is subset or equal to A. A and B are not equal, that is A not equal to B. A is proper subset of B. A is subset of B if and only if A is subset or equal to A not equal to B. A is included in B. That is A is included. This means A is included in B. First one is X belongs to A. Second one A is subset of B. Third one is A equal to B if and only if A is subset or equal to B and B is subset or equal to A. Next, A and B are not equal, that is A not equal to B. A is subset of B if and only if A is subset or equal to B and A not equal to B. A is included in B, that means A is subset or equal to B. A is subset or equal to B. These are the definition of sets, crisp sets, and basic notations. Okay, this is the fuzzy sets introduction and basic definitions. Next we go to the characteristic function or indicator function. Okay, next class we go to characteristic function or indicator function. Okay, function. So these are the basic concepts, definitions, and notations and subset. These are all the notations. Okay ma, is basic definitions and notations and with examples. Next we go to characteristic functions or indicator function, we go to next class. Okay ma, thank you.